Howdy. In this video we will cover section 4.2, Tautologies, based on the textbook First Course in Mathematical Logic by Patrick Suppes and Shirley Hill.
So what is a tautology? Allow me to quote the textbook directly. A molecular sentence is a tautology if it is true no matter what the truth value of the atomic sentences which make it up. Here's an example. It is a square or it is not a square. Now this example is a disjunction, which means that in order for it to be true, at least one option has to be true. So if it is indeed a square, then we have a true disjunction. But even if it is not a square, we still have a true disjunction because this second option is true. So either way, we get something that is true. Thus, we have a tautology. Now, a truth table can help us determine if a sentence is a tautology because a truth table has an exhaustive methodology. It's very straightforward. Step 1, we construct and fill in the molecular sentence's truth table. Second step, we have to answer this question. Is the sentence truth functional outcome always true? And if it's always true, we have a tautology. Let's consider that example. It is a square or it is not a square. We'll create a truth table. S, not S, S or not S. So S can either be true or false. That's it. This is exhaustive. There's no other possibility. Second column, not S, so true to false, false to true. Third column, S or not S. True or false is true. False or true is true. So we end up only at true outcomes. So we have a tautology. Now, by the way, the opposite of a tautology is a contradiction. And contradictions, unlike tautologies, are always false. And of course, tautologies are always true. So consider it is a square and it is not a square. So S and not S. And we can create a truth table. So we have S, not S, S and not S, true or false, false, true, false, false. We can only end up at false outcomes. It is a contradiction. It's always false. There's no way that statement can be true. There's also something in the middle, so to speak. It's a contingency. And a contingency is not a contradiction and it's not a tautology. So what would be the example? Well, if P then Q would be an example. So if P then Q, because if we create a truth table, we will get results that are neither all true nor all false. So true, false. Now, let me fix that. Just be okay, true, 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 false, false, true, false, false. So this is true, this is false, true, true. So we have some true results, we have a false result. So it's neither a contradiction nor is it a tautology, we have a contingency. So we have tautologies, contradictions, contingencies. All right, let's do some exercises. We'll do 3 problems from exercise 2A on page 170 of the textbook. We just want to find out if the given molecular sentence is a tautology or not by the use of a truth table. Number 1 is a biconditional, or also known as equivalency. We have P if and only if Q. So let's get started. We have the atomic sentence P, the atomic sentence Q, and those 2 atomic sentences compose the molecular sentence P if and only if Q. A truth table shows all possible combinations exhaustively. P can be true or false, Q can be true or false. And if we appeal to the principle of multiplication, we know there only could be 4 total possibilities here, right? P can be true, Q can be true. P can be true, Q can be false. P can be false, Q can be true. P can be false, Q can be false. Now in that biconditional, the only way that can be true is if both P and Q simultaneously are true, or they're simultaneously false. So true is true, false is false, true is false, false is true. We get different outcomes. So half of them become true, half of them get the outcome of being false, given the input, so to speak. So it's definitely not a tautology. So not a tautology. But it is a contingency, right? Because you have different possibilities here. You can get something that's true or you can get something that's false, depending upon those truth value inputs, so to speak. So in that sense, you could say the molecular sentence's truth value is variable, and it depends upon the truth value of its atomic sentences. Anyway, let's do number 2. P if and only if P or P. Now, if you remember, this sentential connective by default will be dominant. So if we were going to put parentheses there, we put them here with P or P. Do you think it'll be a tautology or a contradiction or a contingency? Let's do their truth table. So we'll only have one atomic sentence, namely P. There are only two values possible there, right? True or false. In our next column, we'll say P or P. So that's the more minor molecular sentence embedded in that larger molecular sentence. Then we'll say P if and only if, parentheses, P or P, close parentheses. So P can be true or it can be false. P or P. We know P is true, so that's true. P or P. But P is false, so that can only be false. Okay, so now let's look at our biconditional. We have true, true. So this value here is true. This value here is true, so that's true. And then we have false, false. So that's true. So we only can get a true outcome. So this is a tautology. Let's take a stab at number 9. So for the heck of it, I'm going to put this disjunction here in parentheses, only because that's helpful when reading that off. So we have two atomic sentences, P and Q. We have not Q as a molecular sentence. We have this disjunction here, P or not Q. We have this molecular sentence, if P, then not Q. And now we can tackle the entire sentence, parentheses, P or not Q, close parentheses, arrow, parentheses, P, arrow, not Q, close parentheses. All right, two atomic sentences, four possibilities, true, 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 false, false, true, false, false. So now Q is negating this column, so we'll move from true to false, false to true, true to false, false to true. Now we have a disjunction, and we're dealing with this column P and this column not Q. So true or false is true, true or true is true, false or false is false, false or true is true. Now we have a conditional, if P then not Q, so this column and this column. So this column here is the antecedent and this is the consequent. So true, false is false, true, true is true, false, false is true, false, true is true. Now we can tackle our sentence. So we have this guy as the antecedent and this guy as the consequent. Okay, so true, false is false, true, true is true, false, true is true, true, true is true. Well, as we can see, we get different outcomes. So 1 out of the 4 is false, 3 out of 4 is true, so this is definitely not a tautology. It's really a contingency. We'll do one more problem, but this time we'll have 3 atomic sentences, namely P, Q, and R. This is from exercise 2B. How many total combinations are present here? We know that P can either take on 2 values, namely true or false, but so can Q, and so can R. So there'll be 2 cubed combinations, which is the same as saying there are 8 combinations total. And our truth table should reflect it. That is to say, there's 8 possibilities, and they will be listed in that truth table. So we have the atomic sentence P, atomic sentence Q, atomic sentence R. And for convenience, I'm going to put some parentheses in our given sentence. So for this conjunction P and Q and this disjunction Q or R. And as usual, we're going to build up to our entire sentence by looking at the subset molecular sentences that compose that total molecular sentence. So I'll start with, my pen will work. I'll start with this, there we go, P and Q. Then we'll try this Q or R. And then this biconditional, P if and only if Q or R. And then we can do our entire sentence. So the antecedent is P and Q, arrow, and the consequent is P if and only if Q or R. Let's erase some things here. Okay, so there are 8 possibilities, so let's keep that in mind. Start with true, true, true. And what I normally do, I try to rotate between things, keeping certain things fixed. So I'm going to keep P for the first 4 entries as true. And I know that there are only 4 entries in that case because Q and R can either be true or false. Okay, if that makes sense how I explained it. So let me just go through this. So true, true, false, true, false, true, true, false, false. Okay. So there are 4 possibilities there where P is fixed as being true. Now I'll say P is false, and there'll be another 4. So false, true, true, false, true, false, 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 true, false, false, false. And there should be 8 possibilities. So 1, 2, 3, 4, 5, 6, 7, 8. And there's no repeats, so we're good. Let's look at the conjunction P and Q. So we're dealing with this column P and this column Q. And it's a conjunction, it's an and. So true, true and true is true, true and true is true, true and false is false, true and false is false, false and true is false, false and true is false, false and false is false, false and false is false. And now we have a disjunction, and we're still using this column P, Q. So it's a disjunction P or Q. So true or true is true, true or true is true, true or false is true, true or false is true, false or true is true, false or true is true, false or false is false, false or false is false. And now we can deal with this biconditional. So we're dealing with P, this column, and we're dealing with this column, Q or R. Okay. So true, 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 false, false. Did I say that right? I hope I didn't misspeak there. So that's false, true, false. Okay. False, true, false. False, false, true. False, false, true. Okay, that looks good. And now we can address our sentence. So the antecedent, because it's conditional overall, antecedent is P and Q, so it's this column here. And I'm actually going to highlight all of this just to make sure I don't make a mistake. And the consequent is this guy here. Okay. And we have a conditional, as I said, so this right here is the antecedent, and this right here is the consequent. All right. True, true, true. True, true, true. False, true, true. False, true, true. False, false, true. False, false, true. False, true, true. False, true, true. And look what we have. We have only true values. So this is indeed a tautology. So for all combinations, so with all, so to speak, these inputs, these are all the possible inputs, we always get true values. It's a little tedious and it's easy to make mistakes when you're doing these types of problems, but if you focus in, they're not so bad. A little tedious, but they're not really hard.
Well, that's it for this video. Up next is section 4.3, tautological implication and tautological equivalency. I'm the amateur logician.